Hello, this is a review of exponents. Exponents will be a part of our next unit, which is our introduction to polynomials, which we will start towards the end of this week or the beginning of next week. Exponents were covered last year for a couple weeks, so this is just going to be a quick review. If you think you'd like more examples, feel free to email me and I can send you a video or a link to some more examples so you can see them worked out as well. So when we're looking at exponents, there's just two quick pictures here about what exponents are. Exponents are just a way for us to take maybe something that's a little bit longer and shorten it. So the number at the bottom here, which in this case is x, or in this case is 2, is called the base. And then whatever it's to the power of, the number up top here, is the exponent. And sometimes we have a number out front, which we call a coefficient, and it can be 1. Alright, let's jump into some examples. The name of the rules are at the top of each slide, but you won't be required to have memorized these. So the first examples are called the product of powers. So what this does is it looks at what happens when exponents are multiplying together. So in the first example, we have a to the 4th times a to the 13th power. And here, last year, you guys used to practice writing these in expanded form. So if you think about a to the 4th, well, that's a times itself 4 times. So I'd be a times itself 4 times. And then a to the 13th would be the same thing, but 13 times. So I'm going to add 13 more. Notice they don't have to be perfect, but that's saying the same thing in expanded form, so I wrote it out the long way. So now if I wanted to simplify this, all I would do is I would take all of the a's I have written here, and I would put them together. So if I had 4 a's initially right here, and then I had 13 more a's that I multiplied by, all together, I'm multiplying by 17 a's. The way I show that is as a to the 17th power. So that is how I would write a to the 4th times a to the 13th in the simplest way. There is a shorthand rule you guys learned last year. When you are multiplying, so like here a to the 4th times a to the 13th, you can add the exponents. So another way to think about it is as a to the 4th times, or excuse me, plus 13, and that also gives you to a to the 17th. It does work when you have more than one variable. So the second example says y x to the 6th, x to the 8th, and y to the 9th. So in this case, you'll just put the y's together, and then you'll put the x's together, because an x is different than a y. So this y just has a 1 on it. So if I'm going to do the shorthand, what I really have is x to the 6th, x to the 8th, y to the 1st, and then y to the 9th. So I'm going to use the rule we talked about above, because I think that's what a lot of you guys use. So when I do that, I get x to the 6th plus 8, y to the 1 plus 9. And I'm going to simplify those exponents, so I get x to the 14th, y to the 10th. That is my final answer. It's as simplified as it can be. Okay, so our next rule is called power to a power. So it's when we have a base raised to a power and then to another power outside the parentheses. So like this one, I have x to the 5th and then to the 4th power. So what that's really saying is I have 4 x to the 5th. So I have 4 of these. So if I want to write that out, I'd have x to the 5th times x to the 5th times x to the 5th times x to the 5th. That's saying the exact same thing as that is. So I want to simplify that. So if I look at this, I have x to the 5th times x to the 5th times x to the 5th times x to the 5th. That's kind of similar to what we were doing in the last problems where you're multiplying. So if we go back to that, that means we just add all of them, which gives me x to the 20th. That's my final answer here. There is a faster way to get to this. When you have a power to a power, the shortcut way is to multiply the two. So I do x to the 5 times 4, which would bring me back to x to the 20th as well. Still the same final answer depending on how you want to look at it. Okay, negative 3 to the 4th power. Well, the exponent in the parentheses must just be a 1 because there's nothing written there. So if I go by my rule I just talked about, that means I have negative 3 to the 1 times 4. So my final answer would be negative 3 to the 4th power. Okay, next one is power of a product. So all that means is that when I have another power outside the parenthesis, it's going to apply to everything inside. So this A just has a 1 on it, B has a squared. So all that means is it applies to everything inside. So here I'd have A to the 1 times 3, and then B to the 2 times 3. So that 3 outside here applied to everything inside. So my final answer would be A cubed B to the 6th. If you haven't noticed so far, it is like the norm to keep things alphabetical. So notice my A comes first and my B comes second here. All right, with my second one, this 4 is going to apply to everything inside. So I get x to the negative 2 times 4, y to the 3 times 4. And some of you guys maybe don't have to write out this middle step, but I like to. That gives me x to the negative 8, y to the 12. Okay, one more thing you have to remember from last year that showed up here. My steps look good so far, but I don't like to have negative exponents like that negative 8 there. So when that happens, I need to flip it to the other side of the fraction. So right now, this is like the x to the negative 8, y to the 12th are over 1. Since this has a negative exponent, I need to move it to the bottom. So the y to the 12th stays where it was. It's positive, it's good. I'm going to flip the x to the negative 8 to the other side, which will make it positive. And that would be my final answer there. Next one looks at a quotient of powers. So now instead of multiplying, we are dividing. So for this first example, I am going to expand it out. So x to the 10th would mean we have 10 x's all multiplying. And then on the bottom I have x cubed, which is 3 x's multiplying. So now we know from before that if we have something on the top and bottom, it'll cancel. So like this x can cancel with this x, and so on. So then I'm only left with these x's up top. So just from there, I know there's 7 x's multiplying, so I can write that shorthand as x to the 7th. That would be my final answer. Now, a shortcut you guys learned last year is when you are dividing with exponents, you can also subtract instead of working it out longhand. So I do x to the 10 minus 3, which would still also give me x to the 7th. That's another option for you. Okay, I'm going to try the one on the bottom. So again, a's will go with a's, b's with b's. So that gives me a to the 4 minus a negative 3. So I'm subtracting that negative there. And then b to the 12 minus 10. If I simplify that, a to the 4 minus a negative 3 turns to adding. So I get a to the 7th, and b to the 12 minus 10 gives me b squared. Both my exponents are positive, so I am good leaving it in that form. Okay, so now we have positive power of a quotient. So now we're adding another dimension to this, or kind of another layer. We've practiced this before, we're just adding more to it. So this 4 outside the parentheses, let's erase that so I can see a little bit better here, is just going to apply to everything inside again. So now we have things on the top and bottom of the fraction. Well, it still applies to everything in there. So this 2, I don't see an exponent, which means it must be 1. Y and z must have 1. So if I think before, when I had an exponent outside like this, it multiplied by everything inside. So then I would have 2 to the 1 times 4, x to the 3 times 4 over y to the 1 times 4. And again, some of you guys don't maybe need this many steps when you work through that. That's all right. Do what works for you. 2 to the 1 times 4 gives me 2 to the 4. Z to the 3 times, or excuse me, x to the 3 times 4 is x to the 12th. Y to the 1 times 4 is y to the 4. And z to the 1 times 4 is z to the 4. This is good here. The only thing that might be good to simplify further is 2 to the 4th. So that's 2 times 2 times 2 times 2. And that's something we can work out in our head. That gives us 16. So I would say in this case it would be better to rewrite the 2 to the 4th as 16. So I would put my final answer as 16, x to the 12th, y to the 4th, z to the 4th. So it's not necessarily wrong to write it in this format, but I think it is better to write it in the pink one. All right, looking at another example here. So here we have the power of 3 outside. That's going to go to everything inside. Here, the one thing I do notice right away I want to simplify is the c to the 0. Anything to the 0 power is 1. So I can cross that out right away. That 1's not going to affect anything, and that simplifies the problem. So what I'm really working with here is a to the 4th, b to the 4th, a to the 8th. And that's all cubed. So that 3 is going to apply to everything inside. So when I do that, I'm going to get a to the 4th times 3, b to the 4th times 3, and a to the 8 times 3. So I end up with a to the 12th, b to the 12th, and then the bottom, a to the 24th. Now I need to simplify my a's here. I don't want to have 2 a's written in my final answer. That tells me that I can simplify if there is. So my next step would then be, when I have the a's on top and bottom, I would subtract them. So I'd have a to the 12 minus 24, b to the 12, which gives me a to the negative 12, and then b to the 12. So here's where I end up. If you remember from our last side, we don't want to have that negative exponent. So for my very final answer, I'm going to flip that to the bottom. So I'm going to have b to the 12 over a to the positive 12. Now some of you guys maybe could have gotten there from that step, or from this step, excuse me, because you would realize, okay, there's 12 a's on the top and 24 a's on the bottom. So if you cancel a's out, you're going to have 12 a's left on the bottom like we do here. So some of you maybe can reason through that and a different approach, and that's okay. Okay, negative power of a quotient is similar to our other examples, except now we have a negative exponent outside. So what I like to do right away with these problems is, when we have a negative exponent, what we need to do is flip the entire fraction, so the 2/3 becomes 3/2, and that forces our exponent to become a positive 3. And now I would do it just like my previous problems, where that 3 out here goes to everything inside. So I'd have 3 to the 1 times 3 over 2 to the 1 times 3. That leaves me with 3 cubed over 2 cubed. And then I know 3 cubed is 27, 2 cubed is 8. So since those are smaller exponents, I would simplify them to their numbers here, and that would be my final answer. Okay, so if I'm going to start the next example, I'm going to do the exact same thing. I'm going to flip what's inside to force that negative 4 outside to become a positive 4, and then apply the other rules as we've been doing. So I get y to the 2 times 4 over to the 3 times 1 times 4, and then x to the 1 times 4. So remember, when there's not an exponent written, that means there's a 1 there. And that becomes y to the 8 over 3 to the 4, x to the 4. All right, 2 more examples. So the one on the top has some mixed properties that we've talked about. It has negative 3x to the 8th times 2 to the x to the 4th. So here, I'm going to start with the plain numbers, the negative 3 and the 2. Those are multiplying like they normally do, negative 3 times 2. So that gives me negative 6. And then as for the x to the 8th and x to the 4th, if we remember our rules, we add the exponents. So my final answer here would be negative 6x to the 12th. Now some of you guys are saying, wait, there's a negative there, but remember, we just don't like negative exponents. So the negative 6, yep, it's a negative number, but that's okay. And then the 12 here is positive, so that's also okay. Okay, then I have one different example on the bottom here, 49, and then the exponent's a half. Some of you may have seen this before, some of you maybe haven't. When there's fractions up here, it means we're taking the root of something. So 49 to the 1/2 power is the same thing as the square root of 49. So we're asking what number times itself gives us 49. So in this case, our answer could be 7 and negative 7, since 7 times 7 gives us 49, and negative 7 times negative 7 gives us 49. So We just went through a ton of different examples. I encourage you when you're working through the practice to keep your video notes out. Also, there is really good IXL listed. I know you maybe have done it in previous classes, but it's nice because it'll walk you through any mistakes that you might make. Also, feel free to email me. I will get back to you as soon as I can if you have questions or if you're having any trouble with this. Yeah, so give the homework problems a try and let me know if you have any questions. Thanks.